Soaking ourselves in the limitless expanse of the universe, we humans consistently scrutinize the chance of whether we truly are the main species to inhabit a planet. Looking at the stars, thinking about universes far away, and investigating the potential for life beyond our little blue planet, that potential has at last appeared. NASA's chief has just announced that the James Webb Space Telescope has caught something unusual at the extremity of our infinite neighborhood. The James Webb Telescope has focused on Proxima B, the nearby but possibly habitable exoplanet to Earth. We recall that a potential city made by intelligent life had been recognized, which, to date, we don't have the foggiest idea about. The new James Webb discovery shows how the brilliance of the artificial city on Proxima B's lights has expanded. In addition, the synthetic composition of the atmosphere of this exoplanet has been found. NASA's chief has announced that it's possible the JWST, using all of its technology, has succeeded and discovered life on the planet Proxima B. Found just 4.14 light-years from our planetary group, Proxima B has turned into a peculiarity of notoriety because of its actual habitability potential. This exoplanet orbits its parent star, a red dwarf known as Proxima Centauri, which is much smaller and cooler than our Sun. Discovered in 2016, Proxima B lies in the star's habitable zone, also known as the Goldilocks zone, which is the region around the star where the circumstances could permit the presence of water in liquid form, a crucial component of life as we know it. Proxima B's closeness to Earth and its location within the habitable zone have generated a lot of interest and rumors regarding its potential to support life. It is necessary to remember that the habitability of an exoplanet is a complex puzzle, involving numerous variables. Proxima B is classified as an exoplanet with a mass around 1.3 times that of Earth, and has an orbital period of approximately 11 Earth days, meaning it completes one orbit around Proxima Centauri in that time. However, things are not as simple as we might imagine. The fact that the planet is Earth-like in size and orbits a red dwarf doesn't guarantee that it perfectly replicates our world or that we can all relocate there. The habitability of Proxima B is determined by several factors, one of which is the atmosphere of the planet, which serves as a protective shield and plays a crucial role in regulating temperature and supporting life overall. However, the specific structure of Proxima B's atmosphere is still unclear, making it difficult to definitively establish its viability. Researchers at the James Webb Space Telescope are at the forefront of investigating the mysteries of far-off universes like Proxima B. Their constant quest for knowledge drives them to develop creative strategies and instruments to study the atmospheres of exoplanets, with the ultimate objective of revealing evidence of something happening beneath the surface beyond our nearby planetary group. One such tool with tremendous potential is the James Webb Space Telescope, JWST. It is prepared to transform our comprehension of exoplanet atmospheres. The JWST is an excellent advancement in space exploration, boasting exceptional capabilities to unravel the universe by peering far into its mysteries. Equipped with cutting-edge instrumentation and state-of-the-art technology, this observatory is uniquely positioned to tackle some of the most pressing questions in astronomy, including the search for habitable worlds and signs of extraterrestrial life. One of the primary objectives of the JWST is to concentrate on the atmospheres of exoplanets, with a particular focus on identifying molecules that serve as biomarkers, which could act as signs of potential life. To achieve this goal, researchers have developed refined observational techniques that harness the telescope's unparalleled resolution and sensitivity. One such method involves observing transits, a phenomenon where an exoplanet passes in front of its host star, as seen from Earth. During these transits, a portion of the star's light passes through the exoplanet's atmosphere before reaching our telescopes. By analyzing this transmitted light, astronomers can extract valuable data about the structure and composition of the exoplanet's atmosphere. The JWST's instrument collection is specifically designed to capture and analyze the spectral characteristics of exoplanet atmospheres during transits. Spectroscopy, the study of how light is analyzed into its constituent frequencies, lies at the heart of this process. By measuring the absorption or emission of specific wavelengths of light, researchers can detect the presence of key molecules like water, methane, carbon dioxide, and oxygen in the exoplanet's atmosphere. Biomarkers in particular are of interest, molecules that are chemical compounds that could point to the existence of life on a distant world. Examples of potential biomarkers include oxygen, ozone, and certain organic molecules like methane and ammonia. These molecules have biological origins on Earth and may serve as proof of life if detected in the atmosphere of an exoplanet. The JWST's exceptional sensitivity and spectral resolution allow scientists to detect these biomarkers, even in trace amounts, providing crucial insights into the potential habitability of distant worlds. The telescope's long observation times and large aperture allow for detailed observations of numerous transits, boosting the statistical significance of the findings and lowering the level of uncertainty in the data. In the case of Proxima B, the JWST holds enormous potential for unlocking the mysteries of its atmosphere and shedding light on its potential for harboring life. As the closest known exoplanet to Earth, Proxima B presents a unique opportunity for detailed study using the JWST's powerful capabilities. By examining the light that passes through Proxima B's atmosphere during transits, researchers hope to uncover clues about its chemical composition, temperature structure, and climatic conditions. In particular, they will be searching for key signatures of molecules that could indicate the existence of life, like water vapor, carbon dioxide, and possibly oxygen. The JWST's ability to study the atmospheres of distant exoplanets represents a significant step forward in our quest to understand the prevalence and diversity of life universe-wide. By harnessing the telescope's unmatched capabilities, scientists are poised to make revolutionary discoveries that could change our understanding of astrobiology and the search for extraterrestrial intelligence. Beyond focusing on the atmospheres of exoplanets, the JWST will also play a crucial role in advancing our understanding of the broader cosmic landscape, shedding light on a wide range of astrophysical phenomena, from the formation of stars and galaxies to the evolution of planetary systems. The James Webb Space Telescope represents an extraordinary instrument for studying the environments of exoplanets and searching for signs of life beyond our solar system. Another significant factor influencing habitability is the presence of water. Although Proxima B is within the habitable zone, determining whether it has enough water to be considered essential for life is a crucial piece of the puzzle. Scientists are looking for signs of liquid water on the planet's surface, either in the form of lakes or oceans. These clues may hold the key to assessing the possibility of habitability on Proxima B. The presence of water in different states, such as ice or vapor, is also considered, as water availability is essential for sustaining biological processes and is a key indicator of habitability. The presence of Proxima B raises questions about its atmosphere. Researchers will also need to investigate factors like temperature, pressure, and geological activity on Proxima B to assess whether the planet is within a suitable range for life to thrive. Extreme conditions, such as scorching heat or freezing cold, can make survival challenging. Stability is also critical. Volcanic eruptions or seismic activity might cause problems for habitability. Although stability is a good sign, Proxima B is believed to be tidally locked, with one side of the planet enduring perpetual darkness, while the opposite side is always illuminated by the star. The stark contrast between the illuminated and dark sides could create temperature dynamics and variations that affect the planet's habitability. These are a few examples of the aspects that researchers are considering in the search for habitable planets. Researchers are investigating the chemical composition of Proxima B to examine the presence of organic substances, such as amino acids and other molecules necessary for life. They are also analyzing whether the planet receives enough energy from the star or alternative sources to support biological processes and allow organisms to grow, reproduce, and thrive. However, despite all these studies, the question remains, does Proxima B actually have all the necessary ingredients to be considered a habitable planet? The discovery of Proxima B in 2016 was a remarkable achievement. Astronomers used the High Accuracy Radial Velocity Planet Searcher, HARPS instrument, to detect the subtle gravitational pull of an exoplanet in the vicinity of Proxima Centauri, our closest neighboring star. This high-accuracy spectrograph, operating at the La Silla Observatory in Chile, has been instrumental in the discovery of several exoplanets like Proxima B. The HARPS instrument works using the radial velocity method, also known as Doppler spectroscopy. Its ability to detect exoplanets lies in observing the smallest changes in the spectrum of stars caused by the gravitational tug of an orbiting planet. These movements, known as radial velocity or Doppler shifts, occur due to the slight wobble. The most exciting aspects of this: the opportunity to search for life-signaling molecules, biomarkers. These are the same types of substances found in nature that are connected to processes in biology, and the presence of them on a faraway exoplanet could indicate that life exists or has existed there. This search for biomarkers on Proxima B is even more compelling due to the proximity of the planet to the solar system. With its closeness to Earth, Proxima B represents one of the easiest to access aims for research and provides a top opportunity to improve our comprehension of the circumstances that could support existence on other planets. If the JWST discovers these biomarkers in the environment of Proxima B, it would mark a monumental advancement in the field of astrobiology and may have significant implications for our perception of our location. Despite the fact that there are still many challenges ahead, Proxima B's habitability is still a topic of discussion and debate. Researchers must take into account factors like its parent star's stellar flares, Proxima Centauri, which may or may not strip away the planet's atmosphere, reducing its capacity to support life. The planet could be bombarded by these flares with harmful radiation, complicating the possibility for life to take hold. These conditions must be observed by JWST closely to understand how the radiation environment may affect the atmosphere and capabilities of Proxima B to maintain order and support life. The locked nature of Proxima B, where one side always faces the star while the other side remains in perpetual darkness, presents additional obstacles. The side facing the star experiences extreme temperatures, whereas the opposite side may be frigid. Due to the world's dynamics, which are still poorly comprehended, the planet's climate could differ drastically from what we know on Earth. Some scientists speculate that despite these extreme circumstances, it's possible that a tempered zone exists along the planet's terminator, the line between day and night, where liquid water could remain stable. Another important question refers to the possibility of life on Proxima B, even if the planet is not entirely hospitable in the way Earth is. Life as we know it necessitates specific conditions, such as liquid water, a stable climate, and a protective atmosphere. However, it's possible that life could adapt to different conditions that we don't yet fully understand. Just as life on Earth has evolved to thrive in harsh environments, such as the crushing ocean depths or boiling hot springs, life on Proxima B may have discovered means of adjusting to the planet's unique circumstances. If life exists there, it may be completely unlike anything we've encountered, challenging our assumptions about what constitutes a habitable world. As researchers continue their investigations, they are also exploring the potential for future missions to Proxima B. Although current technology prevents us from sending probes to other star systems, future advancements could make interstellar travel a reality. Concepts like the Breakthrough Starshot Initiative aim to develop technologies that could send lightweight probes to Proxima Centauri, opening new avenues for direct investigation. Such probes could be equipped with instruments for gathering data from Proxima B itself, expanding our understanding of the planet's possibility of hosting life. In the interim, The James Webb Space Telescope is poised to provide a wealth of information, pushing the boundaries of human knowledge and offering tantalizing glimpses into a future where humanity might discover evidence of life beyond Earth. The discovery of biomarkers or evidence of life on Proxima B would not only revolutionize our understanding of the universe, but also inspire generations of scientists, engineers, and explorers to continue their quest for knowledge. It would provide an answer to one of humanity's oldest inquiries: are we the only ones in the universe? Scientists are keenly aware that even if Proxima B does not harbor life, the search is far from over. The discovery of exoplanets surrounding stars that extend far beyond our own neighborhood continues at a rapid pace. There are countless other planets in the habitable zones of their stars that remain untouched, and each one represents a potential world where life could exist. The JWST's ability to study the atmospheres of these distant planets offers an unprecedented opportunity to look for obvious signs of life. One of the most exciting aspects of this ongoing research is that it forces us to rethink the concept of habitability. Traditionally, we've looked for planets that closely resemble Earth, but scientists are finding more and more that life might be more resilient and adaptable than we ever thought. For instance, some exoplanets may be tidally locked, like Proxima B, but with unique atmospheric or oceanic conditions that allow for the stability of liquid water or even extreme forms of life. As more exoplanets are studied, it's possible that planets will be found that differ significantly from Earth yet are still able to support life. Looking ahead, the James Webb Space Telescope will remain a cornerstone of astronomical discovery. With its unparalleled ability to investigate the universe and distant worlds, it will unquestionably shape the future of space exploration. Whether we find life on Proxima B or in another corner of the universe, the journey of discovery will continue. For now, the options are endless, and the search to answer the ultimate inquiry, are we alone, remains one of humanity's greatest endeavors.